Hello, hello, hello everyone. I hope you are all doing well. We're finishing up part B, so question 20 from our grade 8 Gauss from 2016 in this video. In the diagram, what is the length of BD? Alright, so we're given coordinates here. Now you might know the formula for the distance between coordinates if you're just given x, y, and x, y. If you want to find the distance between 2 points on the plane, and if you know that, that's great. Use that. That'd be fantastic. If not, what we can do is we can say, well, hey, they're sort of giving us this rectangle. I don't think I need to draw the Cartesian axes. Now, it looks like a rectangle. Does it mean it is a rectangle? Not necessarily. But we can quickly double check by looking at coordinates. Should be C and D have different positions. Okay, so -2, 9, and you'll notice that the x-coordinates here match, so do these ones. And that's what tells you that A is directly above D, and B is directly above C, so these are sort of lines going straight up, and they're parallel to the y-axis. And these other ones, the y-coordinates change from D to C and A to B, and that tells you these are horizontal lines, and so we will get nice little right angles here. So this is, in fact, a square. Or not a square, a rectangle. It doesn't just look like a rectangle, it actually is a rectangle. And we can tell that by looking at the coordinates. Oops, wrong way. So 3 minus 3, and this will be -2 minus 3. Not only that, we can say, well, okay, if we've got right angles here, the distance B to D can be found with this nice little right angle triangle, BCD. Or you could use ABD if you wanted to. Now, what are the side lengths here? Well, what's the distance from A to C? Or sorry, B to C. B to C. Well, since they have the same x-coordinate, the difference between these is going to be the difference in their y-coordinates. So the distance will be 9 minus -3. Similarly, the distance between C and D will be the difference in their x-coordinates, so 3 minus -2. And so this gives me a nice little triangle here with 12 and 5, and BD is the hypotenuse. Okay? So all we need to do is use the Pythagorean theorem to figure out the hypotenuse. So BD squared is BC squared plus CD squared, and that'll be 12 squared plus 5 squared. You can get 144 plus 25, that'll be 169. And if we square root both sides, we'll see that BD is 13. Now, if you know your Pythagorean triples, and I do encourage you to do so, as soon as you saw the 5 and the 12, you might have been immediately able to fill in the 13 here. That could save you time with calculations. Knowing the first few Pythagorean triples, that is to say, sets of 3 integers that form the sides of a right angle triangle, like, 3, 4, 5, 5, 12, 13, some more exotic ones would be 8, 15, and 17. Knowing those allows you to recognize them when you see them on a contest. I think the answer here was A. I think 13 was the first one. But knowing them allows you to recognize them on a contest and skip all this calculation and be able to just sort of mentally jump right to the answer. And that's when you know you're doing math well and quickly. And we've got more time then for the Part C questions that will be coming up. And yes, I was right. It was A, 13. Okay. And speaking of questions coming up, we'll be starting Part C in the next video with question 21.